A long wire carrying a 5 amp current is perpendicular to the XY plane, intersects the x-axis at -2. So we have current carrying wire right here. Long wire perpendicular to the XY plane. So this will be X. This will be Y. That's X equals -2. And this is 5 amps. And a second parallel wire carrying 3 amps intersects the x-axis. So it's parallel, so it's also going to be perpendicular to the XY plane at +2. So I'm going to draw 1, 2, like so. At what point or points in the x-axis is the magnetic field 0 if the two currents are in the same direction and the two currents are in opposite directions? Okay. So, first thing you want to do, let's see, is try and see if it's into or out of the plane, which I don't think it matters. Nope. Okay, so we're going to assume that the current for both of these goes into the plane. So we're going to start with A. A is at what point or points in the x-axis the magnetic field 0 if current's in the same direction. So this will be same direction, A. And I'm going to draw these currents. So the formula we're going to use is magnetic field due to current carrying line is going to be mu naught I over 2 pi r, Ampere's law. A little bit more derivation, worth memorizing. Not understanding is not necessary for this. All right. So magnetic field due to a line, mu naught I over 2 pi r. So the right-hand rule we do for this is we place our thumb in the direction of the current, and then you wrap your fingers around it. So thumb inwards, because they're both going in, and so the fingers are going to wrap this direction. And this can be true for both of them. So what I'm going to do is I'm going to look at the left one first. So the left one, it's going to create magnetic field going up, magnetic field going down. This will be, I'll call this 1, I'll call this 2. And just for clarity, consistency of coloring, this will be 2. And for this, it's going to be down, up, and then down. And I'm going to draw up over here as well, because this is due to this color over here. So really the magnetic field goes around like this, but we're only concerned about on the x-axis. So I'm only drawing the direction of magnetic fields on the x-axis. So draw the other one. Magnetic field goes down for that one over there. So we want to find the place. At what point is the magnitude of magnetic field 0? Yep. And so what we're going to do is we're going to start by looking at this, and we're like, all right, these are the two magnetic fields from 1 and 2, left and right. And to the right and to the left, they reinforce each other, which means they can't cancel out if they're reinforcing each other. Only in the center are they acting in opposite directions. So I'm going to say that this distance right here is x. The distance from the radius from the first wire, wire 1, to the point where they equal 0 is going to be x. And it looks like it's going to the origin. I don't mean that. It's probably going to actually be a little bit closer right there. So I'm going to say that the magnetic field from the left equals the magnetic field from the right. And so I'm going to say, I'll use green for this just so we can see what I'm doing here. So magnetic field 1, which is going to be mu naught I1 2 pi, and then I'm going to call this radius 1, equals, now I'm going to do the other one in blue, just so you're like, oh, okay, that's the other one. So I'm going to say magnetic field 2. Now these aren't actually equal, they're actually opposite. When I add them together, one is positive, one is negative, but it's easier to say they're equal just to, so you see the math. Like, okay, these are equal but opposite. Mu naught I2 over 2 pi, I'm going to call this R2. So we can see right away that the i's are going to cancel, the mu naughts are going to cancel. R1, I said, was x, which means that R2 is going to be, so this distance right here is going to be 4 centimeters, 0.04 meters. You said centimeters, right? Yep, centimeters. So R2 is going to be 0.04 minus x. The idea is you have the total distance, and then when you subtract off the x, this distance right here is going to be 0.04 minus x. That way, when we add them together, 0.04 minus x plus x, we get 0.04. All right, so now we want to solve for x. Oh, the 2 pi's cancel as well. Good call. I know, I always hate getting rid of pi, but such are the sacrifices of life. So I'm going to say that I1 R2 equals I2 R1, just cross multiply. And so we have I1 times 0.04 minus x equals I2 x. We know that I1 is 5 and I2 is 3. So we're going to have 5 times 0.04 minus x equals 3x. Do a little bit more math. 5 times 0.04 is 0.2. Or you could say 0.20, but then you drop the... It doesn't matter. You understand. Minus 5x equals 3x. So we have 0.2 equals 8x. And therefore, x equals, let's see here, 8 goes into 20, 2.5 times. So, is that true? What's going on? 0.2 divided by 8. Let's do 20 divided by 8, just because that seems more obvious, is 2.5. So x equals 2.5 centimeters, 0.025 meters. There we go. I'm like 90% sure on that, but I'm going to put this in a calculator just because I am questioning myself. Bam, 0.025. Yes. So 0.025 meters. And so what that means is, when we go back up here, yep, and that makes sense. I said it was probably going to be over there. It's actually going to be closer to the 3 amps, which makes sense because the 3 amp current is less than the 5 amp current. So it's actually going to be closer to the weaker wire, which makes sense. So x equals 2.5, which means that A, and I know my notations are going confusing here. I'm going to say the 0 point is at 0.5, looks like a 6, should be a 0.5 centimeters. And the reason I say it's 0.5 centimeters is because here the x 2.5 centimeters means that it's 2.5 centimeters to the right of wire 1. Wire 1 is at -2 centimeters. -2 plus 2.5 is 0.5. So that's how we do part A. So for part B, we're going to do the exact same concept. Go through it a little bit quicker though, because it is the exact same concept and we can. So I'm going to redraw the coordinate plane system. We have our 2 wires. This one going to be coming out of the page. and the other one going to be coming out of the page into the page. And so if I look at the magnetic field for it going into the page, it's going to be the same as above, because I think we said they were both going into the page above. Yep. So place your thumb in the direction of the current, and then you wrap your fingers. So it's going to be up, down, up. And then for the coming out of the page, point your thumb outward, wrap your fingers. So it's going to be up, down, up. Does that work? So the problem we're going to have here is the only two maybe we do. Yeah, maybe. We can totally do this. So the center is not going to work because they're reinforcing each other. Therefore, you're not going to get a 0. So this side is not going to work because this is the 5 amp wire. This is the 3 amp wire. And the formula is mu naught I over 2 pi r. Well, basically the magnetic field is going to vary based on the current or the distance. And since the current for the 5 amp is stronger and the distance is smaller, therefore the distance has a stronger effect on the magnetic field for the wire on the left, I would call this 1, then it's going to be, the left wire is going to be stronger in both respects. So there's no way that the right wire can balance it out. So the only potential we have is maybe this wire. So we're going to try and take a look at that and see how this works. So this position here, this distance, I'm going to call x, which means that the distance for the second wire is going to be, let's see here, x minus 0.04, because this distance right here is 0.04. Yes. Yep. Plus. No, minus. Oh, I'm going to draw a better picture. You're right. Hope. Let's do some of this. Okay. So the distance from this wire to our mystery point that we're going to assume is 0 is going to be x. The distance between the two wires is 0.04. Therefore, this distance between the second wire is going to be x minus 0.04. Yes, I'm good with that. So now we're going to say that magnetic field due to 1 equals magnetic field due to 2. They're not really equal, they're actually opposite. I'm just saying they're equal so that I can find them. They're actually equal in opposite signs. So that when we add them together, they equal 0. So we're going to have mu naught I over 2 pi r. And this is going to be 2 pi r1 and I1. Then we're going to have mu naught I2 over 2 pi r2. Mu naughts cancel. 2 pi's cancel. And we have the same formula we did earlier. I1 r2 equals I2 r1. I1 equals 5. I2 equals 3. R2, actually I'm going to say R1 first. R1 we said is x, because it's the distance from the 5 amp wire to our null point. And then we're going to have R2 is going to be x minus 0.04. And so now we can say that we have 5, which is I, times x minus 0.04 equals 3 times x. We have a very similar equation to before. Let's see, is this the exact same equation as before? 5 times, nope, slightly different. So now we can do 5x minus 0.2, because 5 times 0.04 is 0.20, which is the same as 0.2. I know that sounds very lax from a mathematical point of rigor. So 5x minus 3x is 2x, and that equals 0.2. X equals 0.1, which means that x equals 10 centimeters, because it's 0.1 meters. So x equals 10 centimeters means that the distance from the y-axis, from x equals 0, is going to be 8 centimeters, because I'm just subtracting off the 2 centimeters because x is from the 5 amp wire. I know, it gets a bit confusing. I should be more careful. So I'm going to say answer to B, 0 point is 8 centimeters from the y-axis. And really what I should have done is chosen a variable that wasn't x for that, so I could say x equals 8 centimeters. I'm trying to avoid confusion, doing a terrible job, but it gets the job done, and I get the point across. So backtrack to kind of show what we did here. We had, it's a word problem, no picture, so we had to create our own picture. We draw 2 wires, both going into the xy plane. First, the 2 wires are 2 currents are going in the same direction, and then the second part, the currents are going in opposite directions. We want to find out where they cancel out, and so we go with the idea of magnetic field equals mu naught I over 2 pi r. From there, we draw out basically the circle around the wire that creates the magnetic field. We draw the direction, except the only part of the circle we care about is on the x-axis. So we just did up and down arrows. We looked at where the 2 arrows opposed each other, and that's a potential region for where they might cancel out. Because if they point in the same direction, then they're going to reinforce each other, not be constructive interference. And then when they're going opposite direction, we had 2 regions to choose from. And one of the regions wouldn't work because the 5 amp wire is going to be stronger. The magnetic field from the 5 amp wire is going to be stronger than the magnetic field from the 3 amp wire, because it is both closer and has a stronger current through it. So we eliminated the left-hand region from consideration, and we looked at just the right-hand region. We set up some math, and we found an answer that seemed almost reasonable. So that's how we approach this problem. Hope it helped. See you next time.